Welcome to this presentation on stock portfolio optimization using hierarchical equalities contribution or HERC. In this session, we will explore how HERC balances risk across asset groups using clustering methods. This presentation is based on research that applies the HERC methodology to pension funds stock portfolios. It was conducted by Kesla Putri Farhana under the guidance of Dr. Gumgum Darmawan and Dr. Linda Novianti. Pension funds manage long-term investments for retirees. Ensuring stable, risk-balanced portfolios is essential, not just for performance, but for long-term financial security. The idea that high risk brings high return is often misleading. Unbalanced risk can lead to volatility. That's why structured risk allocation like in HERC matters. Hierarchical equalities contribution proposed by Thomas Rafinot in 2018 combines risk parity with hierarchical clustering. It first groups assets by correlation, then distributes risk equally across clusters and assets. In step 1, assets are grouped by similarity using correlation or distance. A dendrogram is formed, creating clusters of similar assets. This structure allows us to organize portfolios around meaningful groupings. Linkage methods define how distance between asset groups is calculated. Single, complete, average, and worst linkage all build different dendrograms. The second step is choosing the optimal number of clusters using silhouette scores. These scores measure how well an asset fits within its cluster. Higher scores mean stronger, more useful groupings for risk allocation. The next step is top-down recursive resection. In this step, risk is distributed recursively, starting from the full portfolio. It's split into two parts, and the process continues until all clusters have their weights assigned. The final step is naive risk parity within clusters. In this step, we assign equal risk contribution to each asset in every cluster until we have the final weights for every asset. The study uses daily price data from January to December 2023. It includes 7 stocks: ASI, BBCA, BBNI, BMRI, BBRI, Telkom, and Deutsche from a real pension fund portfolio. First, we have correlation and Euclidean distance matrix. The correlation matrix shows relationships between stock movements, and the Euclidean distance matrix quantifies their dissimilarities. Using each linkage method, different dendrograms are created. These trees show how assets are grouped based on their similarity and guide the entire HERC process. Each dendrogram is divided into distinct clusters. These clusters become the basis for top-down risk allocation and help us avoid overweighting highly correlated stocks. The next step is top-down recursive resection, and the table shows the weighting results for each cluster based on different linkage methods. And in the next table shows final weights for each stock under different linkage methods. Telkom receives the highest weight while Deutsche consistently receives the lowest, indicating its higher volatility and risk. From this study, portfolios built with HERC outperform the mean variance model and the initial portfolio from the pension fund. Worst linkage delivers the best results in return and Sharpe ratio. On the left, we see risk contributions per asset using different linkage with HERC. On the right, cumulative return graphs show stable growth under the HERC approach, confirming its effectiveness over time. From this research, we conclude that HERC, especially with Ward's method, improves performance by structuring risk across correlated asset clusters. It avoids overexposure, improves diversification, and stabilizes portfolios. Thank you for watching. We hope this session has provided meaningful insights into the hierarchical equalities contribution method and its practical value in portfolio optimization.